Okay, so finally we got lambda equals to 2, 2, 8 are the eigenvalues of given square matrix A. Okay, now you need to find the eigenvector for each of the eigenvalue. Okay, let us start with eigenvector of lambda equals to 2. Since there are 3 eigenvalues, each eigenvalue will have an eigenvector. Okay, so it can be calculated using the equation A minus lambda I into capital X equals to null matrix, where the right hand side O is the null matrix and lambda is the eigenvalue. Here the eigenvalue is 2, I is the identity matrix and A is the given square matrix. So you need to solve the system. The solution is a eigenvector of lambda equals to 2, and the important point is eigenvector cannot be a null matrix. Eigenvector cannot be a null matrix. Okay, now let us start simplify this system, this homogeneous system. Okay, so A is the given square matrix, that is 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. Lambda is the eigenvalue. Here the eigenvalue is 2 and I is the identity matrix 1 0 0 0 1 0 0 0 1 into capital X equals to null matrix. Now let us add corresponding elements. It will be 6 minus 2, 4, minus 2 minus 0 minus 2, 2 minus 0, 2, minus 2 minus 0 minus 2, 3 minus 2, 1, minus 1 minus 0 minus 1, 2 minus 0, 2, minus 1 minus 0 minus 1, 3 minus 2, 1 is equals to into capital X is equals to null matrix. Now you need to solve this homogeneous system so that you will get an eigenvector or you will get a solution matrix capital X. Okay, so from this step there are 2 ways to find the eigenvector. Let us see the first way how to find capital X. Okay, first you need to reduce this coefficient matrix into echelon form. Okay, there are 2 ways in order to find solution for this homogeneous system. So let us see the first method. In the first method you need to reduce this coefficient matrix into echelon form. Okay, so for that I am interchanging the rows. I am interchanging row 1 and row 3. Okay, so it will be 2 minus 1 1 minus 2 1 minus 1 4 minus 2 2 into capital X equals to null matrix. Okay, so there are 2 ways. I am doing the first way. So you need to reduce the given coefficient matrix into echelon form. Okay, now you need to make elements below the diagonal as zeros. In echelon form you need to reduce elements below the diagonal as zeros. Okay, let us apply the row operations. R2 to R2 plus R1 and R3 to R3 minus 2 R1. Okay, so it will be 2 minus 1 1, it will be 0 0 0 0 0 0 into capital X equals to null matrix. Okay, now apply back substitution. Back substitution means writing the matrix notation into system of equations. So it will be 2 into x minus y plus z equals to 0. Okay, assuming capital X as column matrix xyz and multiply this coefficient matrix with column matrix xyz, you will get that equation, and the other equations are with coefficient 0. Okay, now you need to assume some constants. Okay, it will be based on some formula. Now you need to assume some constants. It will be based on some formula. The formula is, you need to consider number of unknowns minus rank of coefficient matrix. Coefficient matrix after reducing into echelon form. Here the number of unknowns are xyz, the unknowns are xyz, number of unknowns are 3, and rank of the coefficient matrix using echelon form, the rank of this coefficient matrix is 1, rank is number of non-zero rows, so the difference is 2. Since the difference is 2, it implies that you need to assume 2 unknowns. Okay, since there are 3 unknowns x, y and z, you need to assume 2 unknowns. Let us assume z as constant k1 and y as constant k2. So you got difference as 2, it implies that you need to assume 2 unknowns. So I assumed z and y. So now substitute z value and y value in the above equation. So it will be 2x minus k2 plus k1 equals to 0. It will be x equals to k2 minus k1 by 2. Okay. Now the final solution or the eigenvector will be xyz, capital X equals to xyz, and it will be k2 minus k1 by 2. Y is k2, z is k1 is the solution or is the eigenvector of lambda equals to 2. Okay, it is the eigenvector of lambda equals to 2. Okay, so eigenvector can be evaluated using 2 approaches. This is one of the approach. By applying echelon form, you can find the eigenvector. Okay, this is one method, and there is other method also. So let us see the other method also. So after knowing the 2 methods, you can apply which is simpler for you. Okay, now let us write equations from this system. Let us write equations, system of equations from this matrix representation. The equations are 4x minus 2y plus 2z equals to 0, minus 2x plus y minus z equals to 0, 2x minus y plus z equals to 0. Okay, now let us identify different equations from these 3 equations. Now identify different equations from these 3 equations. These 2 equations are same because if you multiply third equation by minus, it will be minus 2x plus y minus z. That is same as second equation. And also these 2 are also same. These 2, 1 and 2 are also same because if you multiply second equation by minus 2, it will be 4x minus 2y plus 2z. That is same as first equation. And also 1 and 3 are also same, and also 1 and 3 are same because you multiply third equation by 2, it will be 4x minus 2y plus 2z. Okay, so all the 3 equations are same. Now you write the different equation from all the above. The different equation is, or unique equation is 2x minus y plus z equals to 0. Okay, so you have one equation and you need 3 unknowns. you have one equation and you need three unknowns. Okay, now take the difference, number of unknowns minus number of equations. Unknowns are x, y, z 3 and number of equations is 1, the difference is 2. This difference is saying that you need to assume two values. So let us assume z as some k1 and y as some k2, then x value will be k2 minus k1 by 2. Okay, so the final eigenvector will be capital X equals to xyz, that is equals to k2 minus k1 by 2, k2 k1. Here k1 k2 k3 are arbitrary constants. Okay, and there can be any number of arbitrary constants, there can be any number of solutions here. Okay, so this is the other method to find eigenvector. So one approach is by using echelon form method, the other approach is writing the equations from the matrix representation, then identifying different equations from the system and assuming some values to the unknowns and finally identifying the other unknowns. Okay, so this is the other method, and the previous method is by finding eigenvector using echelon form. So you can apply either method. Okay, so finally eigenvector of 2 is k2 minus k1 by 2, k2 k1. Now there is one more eigenvalue, that is 8. So you need to find eigenvalue for 8. So for this 8 also, let us find the eigenvector in both the methods. So first method is by using echelon form method, the other method is writing system of equations from the matrix representation and identifying different equations and assuming some unknowns. Okay, so two approaches are there. Let us apply both the approaches while finding eigenvector for 8 also. Okay, remember that eigenvector is not a null matrix, capital X, satisfying the equation A minus lambda E into capital X equals to null matrix. Okay, here A is the given matrix, that is 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. Lambda is the eigenvalue, here eigenvalue is 8. Then I is the identity matrix into capital X equals to null matrix. Okay, now add corresponding elements or subtract corresponding elements. It will be minus 2, minus 2, 2, minus 2, minus 5, minus 1, 2 minus 1, minus 5. Okay, so till this step there are two approaches for finding eigenvector. This step is common for both the approaches. Okay, so let us find the eigenvector in the general method, that is using echelon form method. Okay, now echelon form method, you need to identify the diagonal, principal diagonal, and make the elements below the principal diagonal as zeros. Let us make these two elements as 0. For minus 2, operation is R2 minus R1. For 2, operation is R3 minus R1. Okay, so after applying these two row operations, it will be minus 2, minus 2, 2, minus 2, it will be 0, minus 3, minus 1, minus 2, it is minus 3. After adding, it is R3 plus R1, 0, it will be minus 3, it will be minus 3. Okay, now this is the possible diagonal, and you need to make the elements below the diagonal as 0. Still you need to make minus 3 as 0. Now apply the operation R3 to R3 minus R2. Now it will be minus 2, minus 2, 2, 0 minus 3 minus 3 0 0 0 into capital X is equals to null matrix. Now this is the possible diagonal and elements below the diagonal are 0 and no other element can be made as 0, hence it is in echelon form. The rank of this coefficient matrix is number of non-zero rows, that is 2. Now by back substitution means writing the equations by using matrix notation. Okay, it will be minus 2x minus 2y plus 2z is equals to 0 and minus 3y minus 3z equals to 0. Now at this stage you need to consider a difference. The difference has two terms. One term is number of unknowns. Okay, here the unknowns are 3 x, y, z and the other term is rank of the coefficient matrix. Okay, unknowns are 3, rank of the coefficient matrix is 2, so difference is 1. So this difference is saying that you need to assume one unknown. Okay, so let us assume one unknown so that by using that all the remaining unknowns can be easily evaluated. So you need to identify such a variable so that using that variable remaining all unknowns can be calculated. Okay, here there is a chance for z and y also. I assume z as k1. Okay, so substitute z value in minus 3y minus 3z equals to 0, then you got y as minus z and it is minus k1. Now substitute y value and z value in first equation. That is minus 2x minus 2y plus 2z equals to 0. It will be minus 2x minus 2e into minus k1 plus 2e into k1 equals to 0. Minus 2x plus 4k1 is 0. Then x equals to minus 2k1. Now finally eigenvector is column matrix xyz. X value is minus 2k1 and y value is minus k1 and z value is k1. Okay, here k1 is arbitrary constant. Okay, so that means k1 can take any value, any number. So is the eigenvector of lambda equals to 8. Okay, so this is one approach to find eigenvector. So let us see the other approach to find eigenvector for lambda equals to 8. Let us see other approach to find eigenvector. Okay, so till this step it is common for both the methods. Okay, now from this matrix representation you write system of equations. By assuming x as column matrix xyz, we will get minus 2x minus 2y plus 2z equals to 0. Then minus 2x minus 5y minus z equals to 0. Then 2x minus y minus 5z equals to 0. Okay, minus 2x minus 2y plus 2z equals to 0. Minus 2x minus 5y minus z equals to 0. Then 2x minus y minus 5z equals to 0. So out of this system of three equations, let us identify two different equations. Out of this system, let us identify two different equations. These two equations are different because middle coefficient is different. 2, 3 is also different because middle coefficient is different. 1, 3 is also different. All are different equations. So you can choose any two equations. I choose equation 1 and equation 2, that is minus 2x minus 2y plus 2z equals to 0, minus 2x minus 5y minus z equals to 0. Okay, so After the matrix representation, let us write the equations. From the system of equations, identify two different equations. I have identified these two. You can take 1 and 3 also, or you can take 2 and 3 also. Okay. So anything will be, any choice will be correct. Okay. Now you need to find x, y, z values. Okay, the approach is, let us write x by something or is equals to minus y by something is equals to z by something. Okay, let us write x by something minus y by something z by something. Okay, so denominator will be determinant. So we are using alternative approach to find the eigenvector. Okay, so x by minus y by z by, y should always have coefficient as minus. Okay, now you close first column. Write the remaining coefficients in x denominator. Write the remaining coefficients, close the first column, write the remaining coefficients in x denominator, that is minus 2, 2, minus 5, minus 1. Okay, now you close middle column. You take the remaining coefficients into middle denominator. It will be minus 2, 2, minus 2, minus 1. Now you close the last column. Take the coefficients into last denominator. It will be minus 2, minus 2, minus 2, minus 5. Okay, so x by y should always have minus y by z by. The denominators will have determinants. By closing the first column, the coefficients will be in x denominator. By closing second column, the coefficients will be in middle denominator, and by closing last column, the coefficients will be in last denominator. Okay, so these are 2 by 2 determinants. You can expand using AD minus BC. It will be x by 2 plus 10 minus y by 2 plus 4 is z by 10 minus 4. Now it will be x by 12. It is y by minus 6. It is z by 6. Okay, so bring this minus to the denominator. Now finally capital X is equals to 12 minus 6, 6 is the eigenvector of lambda equals to 8. So in the second approach you got 12 minus 6, 6 is the eigenvector. In the previous approach, that is in echelon form method, you got the eigenvector as minus 2k1 minus k1 k1. So both the answers are correct. K1 can be arbitrary constant. At some stage these two will be coincide. For some k1 value, these two column matrix will be coincides. Okay, so this approach is also correct. This approach means writing the equations from the matrix representation and identifying the two different equations and applying this method to find x, y, z values. So this is correct. This is also correct. Okay, first method is echelon form method. The other method is finding the denominator correspondingly. Okay, so whichever method is easy for you, you can apply either method. Okay, so finally a square matrix is given. He is asking for eigenvalues. So we have taken characteristic equation for the eigenvalues and we have simplified the roots of the characteristic equation in two methods. One method is manual method, that is by using synthetic division, and we also used other method to find roots. The other method is using scientific calculator. Okay, here the scientific calculator is unable to give the third root, so we have evaluated the third root using synthetic division only. Okay, and the second question is find the eigenvectors of the eigenvalues. Since the eigenvalues are 2 and 8, 2 will have one eigenvector, previously we calculated, and 8 also have eigenvector. So recently we calculated that. So this is the eigenvector of 8 by using manual method or by using echelon form method. This is the eigenvector. This is also eigenvector of 8 by using shortcut method. Okay, so which is easy, you can apply that. Now let us look another problem on eigenvalues and eigenvectors. Suppose a square matrix is given. The elements are 2, 1, 1, 1, 2, 1, 0, 0, 1. It is of order 3 by 3. Okay, so two questions are asked here. First question is find eigenvalues, and the second question is find eigenvectors corresponding to eigenvalues of this given square matrix A. Okay, now let us start with eigenvalues. So for eigenvalues, you need to start with characteristic equation. So characteristic equation formula is determinant of A minus lambda is equals to 0. Here it will be 2, 1, 1, 1, 2, 1, 0, 0, 1 minus lambda into I is the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 is equals to 0. Now subtract the elements correspondingly. It will be 2 minus lambda 1, 1, 1, 2 minus lambda 1, 0, 0, 1 minus lambda is equals to 0. Now you need to expand this 3 by 3 determinant. Okay, so plus 2 minus lambda into determinant of you close row 1 and column 1. It will be 2 minus lambda 1, 0, 1 minus lambda. Continuation minus 1 into determinant of, now you close row 1 and column 2. The coefficients are 1, 1, 0, 1 minus lambda, then plus 1 into, now you close row 1 and column 3. The coefficients are 1, 2 minus lambda, 0, 0 is equals to 0. Okay, now it is 2 by 2 determinant. The answer is AD minus BC. Now it will be 2 minus lambda into AD minus BC. It will be 2 minus lambda into 1 minus lambda minus 0 minus 1 into 1 minus lambda plus 1 into 0 minus 0 equals to 0. Now you need to simplify this equation. It will be 2 minus lambda in, multiply these two factors. It will be 2 plus lambda square minus 3 lambda, and it will be minus 1 plus lambda equals to 0. Okay, now multiply these two factors. It will be 4 plus 2 lambda square minus 6 lambda minus 2 lambda minus 2 lambda square plus 3 lambda square. Okay, 4 plus 2 lambda square minus 6 lambda minus 2 lambda minus 2 lambda minus lambda cube minus lambda cube plus 3 lambda square minus 1 plus lambda equals to 0. It will be minus lambda cube plus 5 lambda square minus lambda cube plus 5 lambda square minus 7 lambda and the constant is 4 minus 1, 3 equals to 0.